Now we're going to look at velocity versus time graphs. Velocity versus time graphs tell us about velocity as a function of time. So it will tell me what the velocity is in any given moment in time. So is the velocity positive? Okay. Is the velocity negative? Okay, so I can figure out what the velocity is at any given time, but there's more I can tell from this graph. So looking at the intercept, that tells me what the initial velocity is like, v0. What is it? So in this case, it's a positive value. The slope, which tells me about the change of the velocity as time goes on, so the rate of change of velocity, tells me about acceleration. Okay? So the steepness of the slope tells me about the magnitude, so how fast is it changing its velocity. And if it's positive or negative, tells me about direction with which it's changing its velocity, so the direction of the acceleration. It's important to note that if the acceleration is negative, that doesn't necessarily mean it's slowing down. It only tells us the direction of the acceleration. Okay? The third thing it tells us, and this is an interesting one, it tells us that the area under the curve is equal to the displacement, how far it's actually gone. Now, the size of the area tells me about the magnitude, the distance it's gone if it's going in a straight line. If it's above or below the axes, tells me about the direction. So areas above the axis are positive, and areas below the axis are negative displacements. This one also has a lot easier ability to tell you if it's speeding up or slowing down. So if it's speeding up, that means that the line is moving away from the horizontal axis with time. If it's slowing down, it's moving toward the horizontal axis with time. And if it's parallel, it's moving at a constant velocity. So let's look at this picture and kind of pull out some of this information here. So here, my line is moving parallel, so that means it's moving at a constant velocity, which makes sense because my velocity is staying the same number as time goes on. Then I angle down, so it's going toward the horizontal axis, so that means it's slowing down. Let's check that with what we know about acceleration and velocity. If they're opposite directions, it should be slowing down. So at this point here, my velocity is a positive number, so my velocity is positive here. My slope is negative, so my acceleration is negative. Opposite directions, it's slowing down. As soon as it hits this point when the velocity is 0, it is now switched directions. It's moved from the positive side to the negative side. So whenever it crosses over that axis, it is essentially turned around or switched directions of motion. And when it's on this side, it's now moving away from the axis, so therefore it is speeding up. We can check that again. The velocity is a negative number. The slope is negative, so the acceleration is negative. Same direction for acceleration and velocity. It must be speeding up. Now let me show you what I mean by the area under the curve. So in this case, this is the area under the curve. The area that's occupied between the axes, the horizontal axis, and my line.